Hey, John. Yeah, good afternoon. Exactly right. Greetings. So, I just got done with an electrical installation in the living room, so I'm a little sweaty. We put up a new light. Oi, como vai você? Welcome aboard. T. Sanchez Morris. How nice of you to join us from Brazil. What time is it in Brazil? What is the local time? Well, good afternoon, everyone. Welcome aboard. So it's 1300. Okay, so you're 1 hour ahead. Nice. We're sitting at, you can't tell. We're sitting at the Okamoto. It turns out that the Okamoto is my new favorite place to set up office here. So that's where we're broadcasting from. So we're in New Hampshire, and it's a beautiful day here. Sunny. Yesterday was awesome. My beautiful wife went blueberry picking. Hey, Warren. And I posted a picture of the results. Actually, that was yesterday's blueberry picking. That resulted in some peach cobbler this morning. What a treat. After a really energetic Saturday at Taekwondo, I came home with nothing left in the tank. Good morning. So today, yeah, good afternoon, Warren, just barely. Everybody's coming in. That's nice to see. So I've been doing a lot of grinding, as you have already figured out, and really loving the machine. The Okamoto has been spectacular. If I do my job, it does its job. So we have some stories today to tell you. I'll wait till more people show up, but we're doing awesome here for a noon. So believe it or not, my calendar says that tomorrow I'm supposed to have a trainer showing up from Okamoto to start 3 days of training, which was part of the new machine package. And I've talked to the gentleman. He's a good guy, so I'm looking forward to it. Unfortunately, I did not get an email on Friday that nailed down the details, so I don't know what's going to happen tomorrow. So it's going to be very interesting. We'll figure that out later. But if that goes well, I'll have that guy here for 3 days, and I'll do my other work in the evenings. And it's going to be busy. So we've been working on the grinder, discovered a possible discrepancy in my balancing arbor, which I'll show you in a little bit. Because I was examining, let me show you the part that I was looking at. So you may recall that I posted photos of this magnificent part. And if you look at it, it's impossible to photograph, but if you look at it by eye and get the light just right, you can see a little pattern in it, which isn't too surprising because it's 46 grit. But I don't want to see any pattern, so I started looking at everything, and I think I found a discrepancy in my balancing arbor, which may have prevented me from reaching perfect balance in the wheels, and that matters. It matters always. So let's see, I might be able to show you a pattern here. It's very hard to see. Let's see if I can do it. Yeah, I got the light just right. You see this little pattern there? Now you can't feel it and you can't measure it, but you can see it, and that's good enough to drive a perfectionist crazy. Oh, there's Adam the machinist. How is it, Adam, that I said the word perfectionist and you checked in? Hi, Danny. So I was just pointing out that the more I examined my samples, the more I was able to find things. And the truth is, you could always find things. So you may recall that I ground these and then I stoned them. So the PFG Stones. Hey, Cambridge. I don't know if you're in Cambridge. You might live in Somerville. No perfectionist comment. So, the PFG Stones tell the truth, always. So we picked up a little bit of something going on here, and I wanted to hunt it down. Oh, John got the joke. On the other side, I don't think anything showed up on this side, but on that side I saw a little pattern, and it could have been transient. So I started looking at my balancing setup. So as you may or may not be aware, this is my balancing rig. I'm going to be making and selling a kit for these guys, and these are essentially Thompson shafts, very hard shafts, and that's what we're running our balancing arbor on. And I've shown pictures of this before. But what I did is I started, and my friend John at GLG Knife Works was over here. I showed this to him. I started examining the straightness of this shaft. So this is my balancing shaft. We're over here on the big surface plate, which, well, big for me. And here's the setup. We've got the balancing rod in two V blocks, these two little Starrett V blocks. Okay. And on the far one, on this one here, I put a screw in and just clamped it down. Hey, there's Adam, the other Adam. We have two Adams now. We might get up to three. Just as a stop, as a place for the end of the shaft to hit. You'll see why in a minute. And then we've got the 10th indicator. And this is really hard. This is hard to do with two hands. But if we rotate this guy carefully, I don't know if I could do this. You guys might have to trust me. Hang on, I think I knocked something. Yeah, there we go. If we rotate this carefully, we see a little measurable bow in the shaft. And I don't like that. I was measuring 2/1000ths. Yeah, 2/1000ths. So right now, I think I found, hey toolmaker, I think I found a bow in my balancing arbor. Now it's such a small bow, that I think I can press it out. So I think my plan is I'm going to press this out, press, measure, press, measure, press, measure until this guy is 0, 0. Okay, and then I'm going to regrind. I'm going to regrind the taper, and I should be back to perfect again. But this could have been a source of imbalance in my system, and I'm going to go chase it. I'm going to go after it. So that's what we're set up for here. And you can see that there's a little black mark. I've made a little mark, which I show as, I think, the high point. I don't remember. I think it's the high point. So we're going to have a good look at that. And I've got a Greenerd number 3 press, and I have a nice piece of steel. Oh, take care, Warren. I'll catch up with you. Hello, Carl. And I'm going to make a pressing jig, or a bending jig, I should. I don't know if you heard that bell ringing, but my son is trying to FaceTime me. And we're going to try to get this back to perfectly true. I don't know why that was. I'm pretty sure I didn't inspect this a couple of years ago when I made it. So we'll find out. But that's how you find the little tiny things. So we're up to the 3rd level of tool making here, because we're now making tools so that we could make the tools, so that we could make the tools, so that we could make the tools. I think it's 4 levels of tool making, but we've got to get this guy fixed. Let's see how hard it is. Let's see if we could push it with our finger. Let's see. Yeah, let's see if we can get some deflection here. Ready? This is just my fingy. Yeah. So I'm pushing with maybe 3 pounds, maybe 4 pounds of pressure, and we're getting about 3/10. So 1/10 per pound. But there it is. Because as I always say, everything is pasta. And Robin Renzetti says everything is rubber. I think it's pasta because if you boil it long enough, it softens up no matter what it is. And John at GLG Knife Works says he's just a guy making tools for tools. Exactly. We're just tooling around. So this is the latest mini sidetrack project here, and we'll get that sorted out so we can pull the wheels and rebalance them. Oh, and I want to show you one other thing when it comes to grinding wheels. This is very interesting. So this is the Okamoto wheel that came with the grinder, and I did a significant amount of grinding with it. And when I was taking it off of the machine, I noticed that I had inadvertently loosened the nut. Well, it turns out that in order to tighten this nut, you need a spanner, and then you need a way to hold the central part of the hub. Well, if you turn it around, the other side of the hub is full of the 3-weight balancing jig, and there's no way to hold it. I haven't found any way to hold it. So I have to figure out what the design intent was for tightening their non-Sopco hub. So a Sopco hub, it has spanner holes for tightening the nut, and on the other side it has, well, you can't see them because guess whose balancing ring is on here? But they have spanner holes to hold the other side. So it's very easy to get 2 wrenches on it. Let's see if I have a wheel that is not balanced. No, everything is balanced here. Go figure. You sell balancing rings, everything ends up balanced. So, we'll figure it out later. But, I think I have a Sopco hub right here. There we go. So there's a Sopco 0200, or model 200 hub. And on the body of it, it has 2 spanner holes. And on the nut, it has 2 spanner holes. So you could, this, by the way, is why I like to own 2 of those wrenches that Sopco sells. Let me show it to you. So there's Sopco's wrench, and you can use it 2 different ways. But I recommend you always own 2 of them. So I put this in the vise on the bench, pointing up. I put the wheel on it, and then I use the one on top. Sorry for crap signal there, Chris. Not my fault. Anyway, so that's the story. Wrestling a little bit with the Okamoto hub. Now, I will say that it is a balancing hub, so that's pretty cool. And when I do my balancing video, my new balancing video, we're going to talk about how these work also. So that's the Okamoto. Here, let's flip a couple of these over, and I'll show you. Let's get a new one here. That was a prototype. How's that one? There we go. So this is the Kinetic Precision balancing ring, the KP 200. I'm sorry, the KP B200. And this is the Okamoto. So I like the fact that I can take the balancing ring off and put it back on, whereas you're kind of married here to where the weights are. I mean, they both work, but this is better because I sell it. This is better because I sell it. And this goes on the boss of the Sopco Sopco hub. That was designed to retrofit the Sopco 200. So anyway, I got to figure out how to get this guy tightened up, and figure out what the designer intended to happen there, because I'm honestly not sure. But good wheel, good experience with it. It did come in. It seemed to be perfectly balanced, and we had a good time with it. But now we switched over to the diamond wheel. Okay, so that's what's been going on here. Tuning up the arbor for balancing. We're in production on the 6-inch PFG Stones, and I'm very pleased with how that process is working. We got a trainer coming any minute to spend time here and train me on the machine that I've been using continuously for the last couple of weeks. So with that, I'm gonna sit down on my driver's seat here and see what you guys have to say. How are you guys doing? Any questions today? Statements? Bold assertions? False claims? Conspiracy theories? Not so much the conspiracy theories. So today is the first day of August, which is hard to believe. I don't know where the summer has gotten to. It's been kind of crazy. The other thing that's been happening is because I've been doing a bunch of grinding, I was expecting my coolant filter to start using up its roll of paper, right? I see a question came in. We'll jump on it in a second. Yeah, no, I see it came in. So there's the coolant. There's the filter paper, and when the filter paper gets clogged up, the motor automatically moves it in and dumps it into this bucket along with the sludge. And even with the amount of grinding I've been doing, and you can see a little bit of grinding sludge right there, I haven't triggered this thing yet. So it's pretty impressive how much junk this thing will hold. But we have a whole roll of paper. Okay, so let's see what Chris had kick us off with. Yeah, it is. Okay, Chris asks, why are the uprights on the balance fixture so far apart? Wouldn't a shorter distance be better? Outstanding question. Thank you for kicking us off here. Yes, it would be better. And in fact, on the production units, I've already designed it narrower. So, that balancing stand, here's what Chris is asking. Let's just clarify. On the balancing stand, Chris is saying, boy, this is pretty far apart. The hub is only that big. Why have it be so wide? Wouldn't it be better if it was narrow? The answer is yes. Excuse me. It would absolutely be better if it's narrower, and the production units have been designed already to be narrower for the balancing. So, good eye, sir. Good eye. There are a few changes I've made in these in the production units, and you guys will see it real soon now. But that will be shorter. And to Chris's point, if we go over to the back over here, look at how long the rod is. So if we could make the rod shorter, any error, any smile in the rod is going to get smaller. The error gets smaller as we get closer in, because instead of riding, on the rails out here, it's going to ride on the rails in here, and then the delta as it rotates is going to be smaller. So that's a good reason to make it narrower. How does it know to move it? Okay, that's back to a coolant question. I'll show you. I don't know if I can show you. It's hard to see, but I'll explain it. So I hope we answered that question, Chris. By the way, if you have more questions, hit the little question button, and that way we can keep track. So in the machine, in the coolant tank, there's a cover here. There's the roll of paper, okay? And this, I think it comes with a 30 micron paper. And the paper goes let's see, under a rod, and then it starts riding this track. And the track, let's see, we'll look under the skirt here. There we go. So the track is made of this metal, these metal rods and this metal weave, okay? But they shape it. They shape it so that when it goes in here, it makes a little trough this way, and it makes a little trough this way. So there's like a little bowl here, and your coolant comes down this hole, right? It comes down here, it gets dumped in there, it comes down here, and it dumps onto the filter paper. And what you can't quite see is right about here, okay, there's a float switch, just like in a toilet bowl. And when the float switch goes up, because the coolant filter is clogged, it kicks a switch, which is right here. Let's see if we can trigger it. Yeah, we're not powered up yet, so it won't move. But if you could hear the click, it triggers that switch, and then it moves the paper. And I haven't triggered it yet. I'm kind of bummed that I haven't had it move yet. So we'll see how it works. I'm trying not to force it. I want to see what it does on its own. But that's how it works. Yeah. Well, we're powered down. So this is just a plastic bin, and theoretically, this paper, when it comes out, is going to be so full of sludge. Yeah, throw some dirt in there. That's a good idea. it'll be so full of sludge and it'll be wet, it should go right down into here. Oh, you're welcome, buddy. So that's the system, and it's pretty cool. I can't wait to see it do its thing. And you can see in our trough here, we're definitely making some stuff. So I'm quite happy that it's working. Neato. All right. I'm just wiping my hands. Any other questions from the peanut gallery? I have to say that the one of my main complaints about the Okamoto is the extremely poor language translation that goes into the user interface on the screen, and also in the manual. And the conversational programming manual is the worst, and the stuff on the screen is pretty bad. But once you figure it out, it sort of goes away. It's like learning a new language. If the wheel is working, does it reface based on cutting pressure? No. So I bet there's some grinders out in the world that monitor spindle power and make some decisions based on it. This is not a machine that does that. Now, it does, however, make one decision. Okay, so this is grinding wheel load in amps, and there's a little switch in here. This is old analog technology, but pretty reliable. If the grinding wheel load hits the switch that I set, I believe it throws an alarm. Oh, neat. Adam the machinist says Marpos has a vibration feedback system that can trigger dressing. I love that. Yeah, I think when we add a decimal point on the price of the machine, you could start getting that stuff. But this, if we have an overload, like if something bad happens, this machine will alarm out, and you get to set that. In fact, when the machine came, this was set to 20 amps. And when the sales guy was here, he said, yeah, you could probably set that to 15 amps. And after observing it the way I do grinding, I've set this thing to 10 amps. And that's probably plenty. So that's the only thing that it monitors, which is cool. Let's see if I can get the machine up. Yeah. I'll show you how the grinding, how the dressing is set. Let's see. Let's go all the way back home. Main menu, semi-auto, traverse step, grinding condition. The grinding condition screen. So this whole section here is about dressing, and you could say turn the dressing on or off. You could say, do you want to do an initial dress? Do you want any air cut amount on your dress? I don't know why you would do that exactly, but you can do that. And then this is the rough dress, the fine dress. I haven't figured out what they mean here by zero dress. I guess I'll figure that out this week. But down here it says interval, and basically you can say if the grinding wheel has ground 10 thousandths, it's time for dressing. And I have observed it because I was doing something the other day, and I hit the 10 thousandths limit, and the machine said, "Oh, time to go dress," and it stopped what it was doing. It went to dress, and it came back and kept going. And that was pretty pretty neat. So that was a success there. So this is either you tell it to go dress, it hits its interval and it goes and dresses. It switches from rough to fine and it goes and dresses whatever you told it to do for fine. Or it'll do an initial dress when you start. Almost mid-stroke. It actually, the left side of the table, which is to say when the table is to the right, is sort of the magic parking zone, and it will finish the stroke it's in, park itself, and then go dress, and then come back. And I was really impressed with that. So yeah, the dressing works. Of course, I'm on the diamond wheel now. This is the diamond. Let me turn a light on here. There you go. So this is the diamond wheel. So we're not using the auto dresser yet. Maybe one day I'll get that sorted out. But I did see it work. Okay, let's see. We have a question. Let's see. Can the machine dress radii on wheels? Yes, it can. In fact, let's go back to the screen. It's actually wicked cool this way. So Okamoto actually markets this as a form dresser. That's their claim to fame. So if we go into dress setups, we can go dress form select, and we could do all sorts of forming on the wheel. So it's straight dress, convex, which is a full radius. That's what they call a full radius. A side radius, a V, angle, R plus angle. That's radius plus angle, concave, and then this is called original. And original means that it's your definition of the form curve. So this is one of the places where you use G code to define that shape, and then it will do that shape. So yes, the answer is yes. It'll dress whatever you like on it, and the dressers. I'll show the dressers again. Get my cover out of the way here. The dressers are straight dress diamond. Let me put this thing in here. And then 2 45-degree angle diamonds. So 1, 2, 3, and it uses the 3 of them to do the form dressing. And then you can get anything you want. Yeah, it is pretty neat. And I have to tell you, when you first start grinding, like I consider myself still, a student. You don't think of grinding wheels as consumables. And now I realize that they're basically rolls of paper towels. You wouldn't think that now that you've bought a roll of paper towels, you're all set for life. So grinding wheels are just consumables. So you dress them as you need them, and you use them up. And when they're too small, you throw them out and start over. They're not, especially in the white wheels, that you would typically use for doing form dressing, or not the super awesome expensive wheels, but the white wheels are maybe $30. So again, you use them up, you throw them out, but very nice form dressing capability. Good question. And to answer a question that is not yet asked, have I done any form dressing on the wheel yet? I have not, and I'm really looking forward to it. But I think that, like I said, I think the trainer's coming this week, and I believe we don't have a choice. We're going to do that. It'll be a lot of fun. Okay. Chris asks, do you have to vary the RPM as the wheel gets smaller? Another good question. So, you know, it's up to the operator as to what the surface velocity of the wheel needs to be for the process you're doing. And if you want it to always be the same, then there's no automatic system for doing that. That would be kind of cool, and I'm absolutely certain, and Adam, you could probably confirm this, that there are machines out there that will vary their RPM to keep the surface speed constant over time. But this machine does not do that. In fact, the RPM of the wheel is controlled by two analog knobs, and then you get to measure your wheel speed on an analog meter, which I think is quite quaint. Now you have two knobs because you can set a dressing speed and a grinding speed, and then when you turn the wheel on, or when the machine controls the wheel, it's going to choose grinding or dressing. So when it auto dresses, it stops and it goes to auto dress, it will be on the dressing speed, and when it comes back to do grinding, it will switch back to grinding speed. And yes, it will wait until the RPM stabilizes, which I think is pretty neat. And I'm not sure how small I would go on the wheel before declaring it's used up, but this machine will take 8-inch wheels, and I've only been using 7-inch wheels. I think 7-inch wheels are more common, and I don't know why. There's probably some history there. But the white wheel I showed you earlier, which came from the factory, is an 8-inch wheel. So I might change my tune and start buying 8-inch wheels after I use up what I got. At least they'll last a little longer. Excellent questions. So I'm also interested in doing some tests on different materials, and that's coming up shortly. But I also have to get PFG stones out because the orders are not stopping, and I'm grateful for that. And the recipe we have set up on the new machine is working beautifully. Very happy with that. And yeah, so we have to keep on grinding. Excellent. Any other questions today? What are you guys doing? What are you guys working on? Tell me what you're working on in the comments. Hey, while we're waiting for questions to pop in, my friend John over at GLG Knife Works, that's GLG Knife Works, is holding a Instagram live at 1 o'clock, so top of the hour, and he's a good guy. So go say hi and learn something about his business. He makes non-conductive knives. So, you did a 5-mile walk. That's beautiful. Circular saw blades that take carbide indexable inserts. Wow, that's what you're working on now? That is neat. Carbide indexable inserts. Adam, that sounds like a big tool. That sounds really cool. You notice that, yeah, okay, I guessed it, huh? I guessed the size. Yeah, there's a few of us here that you're high-speed milling the insert teeth. Oh, that's awesome. What is your cutting tool in the mill? We were just listening to the Business of Machining, and John Grimsmo is just investigating some end mills that are CBN but they're tiny, teeny weeny. And he mentioned your name, Adam, actually, as being a source of some information on milling of hardened materials. Union tool, 0.3 millimeter diameter by 3 millimeter long. So the first thing we notice is that's a 10x long mill. So forget the absolute value of the diameter. That's pretty impressive. And now you can look at the absolute diameter, which is 0.3 millimeter. Oh my gosh, that's about 12 thousandths or something. That's really tiny. That is smaller than I've ever milled with. That's amazing. So yeah, the smallest I've ever milled with was, I think 20 thousandths is the smallest mill that I've ever used. And I was shocked at how long it lasted and how nice a job it did. And it was an aluminum, I admit, nothing exotic. But if you follow the rules and you do the numbers and you have good coolant clearing out the swarf, that it's still mounted up. It's in my tool rack right now. It didn't even wear it. I was so, and it did about 7 hours of milling in aluminum, and you put it under the microscope, and it was just fine. Very neat. Hey, Adam, maybe next week, think about this, maybe next week we'll figure out the system to bring you in as a guest on, and we could have you live. Let me know if you want to do that, but there is a way to do that here, and I haven't successfully exercised it. I think we did it once, and we did it accidentally once. All right, well, it's 12:42. Any other questions, guys? Happy to answer anything at all. Almost anything at all. So, okay, you want me to make you feel better? I'm wearing my OSHA-approved sweatpants and PFG flip-flops, so don't feel bad. As long as you have the pajamas with the steel toes, Adam, you're fine. This is one huge advantage of having the shop attached to the house, is that you can wander out to the shop anytime you want and get something done, and you don't have to dress up, and you don't have to put on the well, you do have to put on your safety equipment. Hex Manufacturing, welcome aboard. Glad you could make it. Although we're getting toward the end of the session here. Oh, we have a question just popped in. Stand by. So has the Shoreline Mill been getting any love, and do you have any comments on the machine? I sold the Shoreline, and like many machines, not all, but many machines, I'm sorry I did. I kind of wish I still had it, but it's long gone. Oh, a bunch of guys just checked in. Hi guys, welcome aboard. I think the Shoreline Mill and the Shoreline Lathe were awesome ways to learn how to machine. I mean, from zero, right? It's like, I want to figure out what this is all about. They were great, and they did a lot of good work. And one of these days, I'll show some bits and pieces from those days. But if you have somebody who's just starting in machining, or, well, yeah, just somebody who's just starting in machining, or somebody who is a machinist, maybe at the job, and at home they want to tinker and maybe build some small stuff. I think they're fantastic. And when I you know, I got my first one in probably 88-ish, 89-ish. I don't know, somewhere back there. And it was a great tool. I wish I had it. It doesn't take up a lot of room. You can put it up on a shelf. You can put it down in the basement on a shelf. If I, you know, at the time, you don't, hey Octane, you don't think about this stuff, and it was small enough that I could have kept it. Probably should have. That would have been cool. So yeah, highly recommended. At least back then, the quality was very nice. I know there were some watchmakers that use them still, and the company is still around, even though the founder passed. And yeah, go check them out. Not sponsored, but I like them, and I would recommend them. And there's a CNC version of it. I don't know if they sell it or they sell it up to the motor mounts, but it's very CNCable. Hex Manufacturing asks, what got you into machining? So, on the podcast with Intolerance, where I did an interview, a very long interview, I tell the whole story, but I'll tell you the brief version here. So I was at MIT as an electrical engineering student, and my roommate was a mechanical engineer. And, well, let me back up, because actually before that, I was working for a company during the summer, and I took a semester off plus a summer, and I worked for Bulova Systems and Instruments. And during that time, I was into cycling, and I had a pair of brakes that I was putting on this bicycle, and they didn't fit properly. So I went to the old school machinist, and I explained my problem, and I said I needed some bushings to make these bicycle brakes fit properly. So at lunchtime, he called me over, and he handed, I remember he put in my hands I think it was 2 or 4 bushings that I needed for this job. And sitting on his bench was a South Bend 9-inch lathe. And this guy was a old school German machinist, golden hands, and he'd been working for Bulova for many years. And I was sort of like, okay, I need to learn this, because he just made a thing for me. Hey, happy Sunday, Octane. He made a thing for me, and that sort of started the process. And then I got back to school, and my roommate said, hey, I'm going over to the mechanical engineering lab, and do you want to come with me? Now, ironically, our buddy, hang on, let me get the exact name here, or the handle. Where are you? Here we go. The Machine Shop 10EE. I think he will understand which machine shop I was in. It was the mechanical engineering student machine shop. And he says, I got to do a project. You want to come over? I said, sure. Will you set me up on a lathe? Or I forget exactly how I asked, but I said, would you set me up so I could do a little machining? I've never done it before. He said, sure, come on over. So he set me up on a lathe and gave me a piece of scrap, and I started turning. And I'm like, this is cool. And then after, I don't know, probably an hour and a half of that, he said, look, I got more stuff to do. Do you want to keep going? I said, sure. He says, you want to learn how to use a Bridgeport? And I said, yes, I do. So he set me up on the Bridgeport. I made my first chips on a Bridgeport, and that was it. I was done. So when I got into, So do you know which lab I'm referring to? Was I unambiguous? I'm not sure if that was enough information. So when I got into further down my engineering career and I got into antennas, I started making my own antennas, and then when I started consulting, I started making prototypes for my customers. And if you've ever used a light dimmer on called a Lutron light dimmer, Lutron company made a bunch, and I designed some antennas for their wireless. Yeah, it might be the one you work in. I'll have to figure that out one day. Oh yeah, I got the bug bad. So the Shurlines were purchased when I was just starting my antenna consulting, and then I used it for you didn't wear those Bridgeports out yet? Anyway, so that's the short answer. From there, it was a steady slide. I refer you to the podcast where I think I go over every machine that led me to today, to the most recent machine that we're leaning on right now. So I hope I answered the question. I'm still an electrical engineer. I still design antennas. That is my main gig. But antennas are weird, Antennas are electrical, antennas are mechanical, and, all of those things. Yeah. Thanks for asking. A lot of fun. You can see there's remnants. There's a parabolic dish sitting up there waiting for the next project. If you guys want, I'll show you some antennas for the next live. I see a lot of hearts showing up. Maybe that's a yes. But I could show some antennas. I could show one antenna that is all machining, and it came out pretty nice, and that was delivered to a customer. So we'll do that. All right, it's 12:52. I'm gonna allow 5 more minutes, I think, and then I'm gonna call it. Any last minute questions? Yes to antennas. Okay, we'll do antennas next time. Unless something comes up and I have to push it out. But I will have to stage 3 or 4 antennas to show you. And I could also do a live one day in my electronics lab if you want to see the lab. Of course, that means I have to clean it up. But that is literally right up. Actually, it's the other side of the shop, upstairs. That's my lab. What grade grinding wheel for SPKNL with 64 HRC? I don't know what SPKNL means. So I don't know what material we're talking about. And 64 HRC doesn't scare me at all. And hex manufacturing, yes, I guess, yes for the lab, right? We'll do a lab day. Also, we've been doing this at noon or 1600 UTC on Sundays. If anybody feels very strongly that we need to move it a little bit, let me know. Oh, and one last commercial for my friend John at GLG Knife Works. He's going to start an IG live at the top of the hour. So look him up. Look up GLG Knife Works. He's probably cleaning up right now from all the dust. Yes for the lab. No problem. Yeah, we'll do a lab day. What the heck? There he is. So yeah, show up for John's live. He's eating a snack. Yeah, there's no stop. Once you start this, John, there's no stopping. So never start one of these if you haven't had a good peach cobbler with vanilla ice cream. Okay. Come on, one more question. Then we're going to wrap it. We have room for one more. Yeah, it was fantastic. So Chandra, my wife, went blueberry picking yesterday and the day before, I think. And we have blueberries now. So they are amazingly yummy. Does frequency of the grinding wheel turning influence the grind? That's a really good question. I think you mean, does the RPM influence the grind? Is that even a thing? Yeah, it does. The biggest influence is on imbalances in the system and vibrations in the system. You can tune that to get the wheel and all the vibrations to be at a minimum, and that's actually a thing. But also, it depends on the material you're running. You can burn material by using the wrong combination of wheels and RPMs and stuff, but it's not like a really critical parameter. Any good MIT jokes? Yeah. Okay, we're going to close with this, guys, because Adam asked the ultimate question here. So, do I have your permission to be a little crass? Can I be crass? Is that okay? I mean, I don't want to insult anyone or offend anyone. Yeah. So this MIT guy and this Harvard guy are out in the men's room at adjacent urinals. And the guy from Harvard finishes his business and goes over and starts washing his hands. And the guy from MIT finishes his business and heads for the door. And the guy from Harvard turns to him and says, "At Harvard, we are taught to wash our hands after we use the bathroom." The guy from MIT says, "At MIT, we're taught not to piss on our hands." And with that, I'm going to say have a nice Sunday, guys. And Adam, you're going to make me think up more for next week? I don't know if that's fair. All right, so with that, it's 12:57. We're on time. You guys are out of control. Oh, you're showing up at the last minute. You know, I'll tell you, you could be an MIT student for showing up at the last minute. I do not want to dwell on MIT. Mind you, I love the place, but that's not what we're here for. All right, but I will, in honor of Adam the Machinist, we will come up with at least another MIT joke. So guys, have an awesome Sunday, and we'll see you next week. I got work to do. See ya.